Coffee stains and nipple chains. I am such a loner. San Francisco faces got me slowly taking over. I can't wait to show you that I'm gonna take it over. Lico, beast mode, 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 Lico, beast mode. This is not a main thing, really I'm a coder. Coffee stains and nipple chains, I am such a loner. San Francisco faces got me slowly taking over. I can't wait to show you that I'm gonna take it over. Lico, beast mode, 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 Lico, beast mode.
Chat. Day 11, Advent of Code. Michael said we're gonna make it out the trenches with this song, 100%. I hope you're listening to it. I hope it gets you into the mood to do some algos. I hope you're hitting some lead code hards, mediums, listening to it right before you go into your final rounds, your exams, everything. Trust me. This is the type of stuff I was playing. Literally play the song over and over before my interviews, and that's how I get prepared. I'm gonna turn it into a TikTok song, and people should start actually bumping it. Michael, you like the song? Yeah, we got 12 minutes. Write some code. It's time to code. Advent of code. Wait, I'm trying to push out a feature real quick. Alex, what's up? What am I gonna do? I'm trying to push out a quick feature, Codex. I asked Codex to make me a feature. We got 10 minutes, so I want to quickly look at some. I'm trying to build like this GitHub heat map looking thing. Then we're gonna get into Advent of Code. Alex, what are you up to these days? Woo-hoo-hoo. No way. What is this? Yo, this is a heat map of like all my posts. How did it work? What did they do? Damn, I went crazy in February and March. Where do I update the code? GPT Opus. Robin, what's up? You ready for day 11? We're getting really close. I hope we finish off strong. Let's run it. Yo, I built a heat map of when I posted all year, and I was going crazy. This looks messed, a bit messed. Like in February and April, I was posting pretty much every day. Grab something. Yes, sir. We're almost there. We're almost at 200. 200. Oh, this is sick. Yo, look at this. Shows like all the different videos I posted. This is so funny. Holy. I went crazy this day. Saturday, December 6th. Man, I love vibe coding. Do I even got any free time? A little bit. I chilled out there. Okay, let's integrate this into. Look, I dropped 525 hours of content. In just a year. Yo, Alpha, look, I built a little like GitHub thing so I post all my YouTube data. Yeah, I upgraded you. I'm gonna upgrade Paul too soon. Let's see. Yo, look at this. So, Alpha, check this out. You can hit all these. So you can like click on some of the videos and just go straight to it. It's like a YouTube heat map. Jokes. Yeah, this was like downtime. You should do one like this, Alpha, because you've been posting for years. And then just like be able to see like all the videos and what you posted start of the year. That man got upgraded. Alpha, you have a GitHub? What does your GitHub look like? Mine's lacking. Damn, I've been posting more on. Ooh, what is this? What? There. This is the one thing I want vibe code. Damn, it still did it better than me. $50 test migration? That's a lot. This. Nice. Damn. Then I'm gonna add like filters for the year. Or like be able to like check by the year. See stuff that I was posting. Yo, I'm gonna do a bunch of stuff. Alpha, you working late again today? Nice. Respect. Trying to get ahead. Makes sense though. All right, advent of code, day 11. This is gonna be rough. All right, day 9 and 10 was like part 2 was like some crazy competitive programming stuff. One involved row echelon form, like linear algebra, backtracking or something, and the other one was like some other geometry. Cyclops, have you actually been trying it yourself too? Yeah, we had an Oracle director. He's like 17 years. Yeah, Alpha, maybe. So basically, Alpha, how he got into the chat was that he finished. He finished. He was able to finish day 10 part 2 by running it through some SciPy function, but then what he did was he was trying to look for other people who were doing it and see what their solution was. Then he joined in. So he's literally like a director at Oracle. Worked there 17 years. He's like the director of product development or something, and then he just does advent of code for fun. But I think definitely in 26 we're gonna grind out more. I'm gonna get into code forces in 2026 maybe. We'll see. Code forces and AI, just like work on some hard stuff all year and see where we get. No more easy stuff. No more reversing a linked list. All right, day 11. Wait, let me get this ready. I know, but I'm not gonna sell out. Yeah. But I feel like people watch Code Force's content. A little bit of prep. Bro, there's like that little kid who does like 1,000 ELO questions and people still watch. Now I'll probably do a series where I try to get to like 1,600 or 1,800 ELO. Literally my goal. All the Code Force solutions are in Hindi. Yeah, exactly. Yo, that might be a niche we could break into, Alpha. Code Force's solutions. Just like Python in English. If that's not a thing right now. But maybe my goal is next year I want to get to like 2,000 ELO lead code and maybe 1,750 code force or something. I don't even know. We'll see. It's hard to do lead code contests during the day. All right. Day 11. Reactor. You hear some loud beeping coming from the hatch in the floor of the factory, so you decide to check it out. Inside, you find several large electrical things and a ladder. Climbing down the ladder, you discover the source of the beeping. A large reactor which powers the factory above. Some elves here are running between the reactor and a nearby server rack, apparently trying to fix something. One of the elves notices you and rushes over. It's a good thing that you're here. We just installed a new server rack, but we aren't having any luck getting the reactor to communicate with it. You glance down the room and see a tangle of cables and devices running from the server rack to the reactor. She rushes off, returning a moment later with a list of devices and their outputs, which is our puzzle input. For example, we have this list. Each line gives you the name of the device followed by a list of devices to which its outputs are attached. So BBB, DDD, EE means that the device BBB has two outputs, one leading to device DDD and the other leading to EE. Sounds like a graph question already. The elves are pretty sure that the issue isn't due to any specific device, but rather that the issue is triggered by data following some specific path through the devices. Data only ever flows from a device through its outputs. It can't flow backwards. After dividing up the work, the elves would like you to focus on the devices starting with the one next to you. An elf hastily attaches a label which just says you, and ending with the main output to the reactor, which is the device with the label out. Okay. To help the elves figure out which path is causing the issue, you need to find every path from you to out. In this example, there are all of the paths from you to out. These are all the paths from you to out. There's 5 different ways. How many different paths lead from you to out? It sounds just like it's like a backtracking or a DFS question. So these are the inputs. From you to BB. You. So this is us. This is the starting. So you goes to. So we have you. It's saying it flows through BB and CC. Yeah, basically a tree. From U to BB, then from BB to D. How do you get from BB to DD? Okay. BB goes to DD and EE. So it kind of goes like this. Oh no, there's but BB also goes to EE. I think we just literally need to make a graph on this. Then from DD to GG. Then GG to out. Okay. You have to find every unique path though. Data control. Then EE. Okay. Data can go from U to CC. And then we say CC. Okay. So is there no cycles? BB. Yeah, there might be no cycles. Okay, I guess we just it's just a graph question. We just need to build the adjacency list. So we build the adjacency list with we parse each line and then we split by this. And then the key will be the node, like U. and then we create a list of all of the different neighbors, and we literally do that for each one, and then we just perform a DFS starting at U, and then every time we reach out, we wait, is there multiple ways out? GG to out. CC, then DD, then CC. Okay, CC. Yeah, we just need to explore all the ways. Like the most brute force is just backtrack it. Every time you get to a out, you're done. And then you count it, and then you just try every single way. And then maybe we can soon we can start caching. Well, because if we already got to DD, right? And we know that DD you can exit like 3 times. If we get to CC and we get to DD, we know that like we can get to this other path, like that creates 3 more paths. Like if this goes out 3 times, right? So we like eventually, and then if we just pre-calculate that, then we're good. Let's just like parse out the input, and then from there we're gonna perform just a simple backtracking. Woo. Or like not a simple, like a simple DFS, and just try to visit every single node. Like, yeah, we'll just do a DFS. Every time we get to the out, we could just do it recursively. Are we sure there's no cycles? Okay, let's start implementing it. Let's start implementing this real quick. Test out this. Import. No problem, man. For a line in input, we're going to split by this node, or we'll do first split equals line dot split by this. Then we'll say node equals facts, and picking good. For the last 2 days though, did you see the part 2? They're not easy. Thoughts on quant trading? No idea. I'm not in it. It sounds sick. Make a lot of money. It's hard. Everyone I know who's done it is like crazy math nerd. Like if they're actually a quant. For neighbor. What's the AI bill? They probably like host it locally or something. No idea, bro. I don't know if I can comment on that. It's insider info, right? HUBBBCC. Okay, now we just have the adjacency list. What we're gonna do is we're gonna do stack, or yeah, we'll just do like simple recursions. Stack. While stack. We said that there's no cycles. We'll see. While the stack, and you put U. Dot pop for neighbor. Oh, continue. I won't even throw this into a function, but we'll do adjacency list of candidate. Don't tell me it's that easy. Don't tell me it's that easy. Don't tell me it's that easy. Let's go. Let's go. Harold, long time. Don't tell me it's that easy. We got 1 star. They're going easy on us today. Let's see where we stack up on the leaderboard. What? There's definitely a global leaderboard. Okay, we're the 827th. That was the easy one. Let's see part 2 though. What? Did they talk about fast Fourier transform already? Thanks. In part 2 to your analysis, the elves have figured out a little bit about the issue. They know that the problematic data path passes through both DAC, a digital to analog converter, and FFT, a device which performs a fast Fourier transform. They're still not sure which specific path is the problem, and so they now need to know how to find every path from SVR to the server rack to L. However, the paths you find must also visit both DAC and FFT in any order. Okay. Yo, Paul, what's up, man? Nice to see you in the office today. It's not is it hard? For example, For example, this new list of devices must contain This new list of devices contains many paths from SVR to out. However, only 2 paths from SVR to out visit both DAC and FFT. Find all the paths that lead from SVR to OUT to out. Yeah, it's just literally just like a backtracking problem. Same input. Dude, why'd they go easy on us? No, I'm not saving the path. But I didn't do it recursively. I have to do this recursively. Node. Path. If we're enabling adjacency list. Candidate. Node. We need to just convert this to recursive. DFS neighbor path. Let's see if this just works with our last code. What's our adjacency list? Oh. Shoot, I forgot to copy and paste. No, I'm just testing the old code real quick. Or I'm just converting it, and then we're testing. If the node equals out. Oh. Perfect. So I think what we're going to need to do is, we're going to count. We're going to count not just like the path, but we're just in each path, we're going to just count like the occurrences of what we saw. We're going to count the occurrences of what we saw. And we're going to start at SVR. So when we see a node, what we're going to do is like path node plus equals 1. I see. Yeah. Let me try this first. And I'll convert it to DP. If we see greater than 0. Damn, we got 2 alphas in the chat. Agents first cause right now working towards more data related. Is there any advice? How come you want to work on data related stuff? Why not just SWE? I'm big biased towards SWE. Yeah, Paul's a data eng right now. Okay, it's not finishing. I have to do some DP. Zero. Let's debug the actual path. We'll append the node. Oh, sorry, I'm running part 2. Wait. I see. You like the analyzing side of coding here. Why does this only run once? SCR. What? So we start with a default dict and we have an adjacency list. What's going on here? Adjacency list. Wait, they gave us a new list? Okay. There. Sorry, there's a wrong list. But it looks like we have it. Okay, we just need to do DP now. If we got to a specific node. Scene. DC. Yo, cool, what's up? Oh shoot. Tweaked. Yo, we might actually get to sleep early today. Wait. I've been running low on sleep because we've just been grinding these out. Okay. Yeah, I think we just need to, like, DD. We could have seen it. It's like a 3D. Seen it. Like DD. Like the node. Seen, and then just like a flag. Cool. Cool. And those are our states. Scene DC scene. If we get to out and scene DAC and scene FFT, return 1. Cache. Node. Scene DAC. Scene FFT. If in cache, return. Result. Is node DAC. That would digital to analog. Okay. Scene DC. Scene FFT. Or yo, Alpha 12177. I'll give you my take on that in a sec. Woo! That took forever to run. Damn, got used to a hack. SVR path. Oh, we don't want a path no more. node. No cache. Let's go. We finished day 11. 30 minutes. That's a record. For me. Easy. Alright, y'all want to try day 9, 10, and 11 again? Hold up. 9 and 10? Holy no. Hold up. Let me post this quick. Has to go live. Yeah, that was too easy. Some dude finished it in 8 minutes. I guess you need to know a little bit of DP, but that's like a very basic DP solution. Not gonna lie. Hold up, let me post this. Let me post this, then I'll answer your question. Then maybe we can try day... Let's look at day 10 again. Bro, day 10 was hard. Or like maybe I can solve day 9 again. Day 9. Get to day 9. Dude, day 9 was difficult. Let me quickly post this. Doing wrong here? Day 11. Yo, I swear, we need to get the Code Forces Master, the guy, to come in and see how he would have done day 9 and 10. I wonder if he would have just straight destroyed it. One sec. Let me just quickly. So I'm just posting something on some other. So we're gonna get into this. Alpha, did you try day 9? Day 9 part 2? I gotta get the views. Let me post this for everyone else. But I can't. We just destroyed that. Then probably do. It's good, bro. tweak. Okay, yo. Wait, internal error? Hold up, I'm trying to post something real quick. Okay. Yo, Alpha, what exactly did you ask? Let me read. There's like two alphas. Okay, I'm gonna read this. Hey James, I'm a freshman in college right now working towards more data related careers. Is there any advice that you can give me? If you're working for data related careers, that doesn't sound good. Well, I'll be honest. I just like analyzing the analyzing side of coding more than the development side of it, hence data science. I want to get more financial data analysis. Well, I was always been a fan of financial markets, and from what I've learned from the professors, it does sound interesting, if that makes sense. I mean, I'm still a freshman, so I do have very unreasonable goals, but from what I'm interested in, quant research is the most relatable career. Is UW Madison a target school? Well, I'm definitely not applying share. I'm definitely doing a master's either in quant finance or at CMU. Which you want to go to University of Michigan for undergrad? Take on your situation. I would say you're just a freshman. Honestly, I don't know much about quant finance, so I don't know what people actually take to get into quant finance. But I do know if you just take a general computer science degree, maybe like I know a lot of people from like Waterloo who would just take a general computer science degree and then maybe they'll do like a little bit of electrical engineering and they'll land jobs at Citadel, Jane Street. All the people that I know who were landed in those hedge funds are just regular computer science students. So they I'm pretty sure with a lot of those roles, they're going to make you code and do algorithms for the interview. And so you need to be able to code, I'm pretty sure. Like there's probably I don't know much about the quant interview, but I definitely know that you're gonna have to code. You're gonna have to learn how to code. Like from what I know, like the quant, like a lot of like the data science quant people, like there's like two roles. So there's like there's like the quant analyst. Yo, Mertizzi, long time. And then there's like the quantitative developers. So I think like the quant, like the quants who have more of like an analytical background, like develop some of the models, but then some of the quantitative developers actually go and implement it. I mean, go follow Coding Jesus. His whole thing is about quant space, and he works in the quant space. Honestly, I'm not really into quant space, so I can't really give advice on that. But what I would say is like there's a lot of money to be made if you still have a computer science degree and you're really good at it. If you look at all the people starting a lot of these companies, like Cursor and all those other companies, like those new unicorns, they all have a computer science background. So what's your product? What's your product, man? I'm just like editing my thumbnail quick so I can drop it. Drop that video. Hold up. Then maybe we'll get into day 9. Zero track. Mertizzi, you're looking for a new job? Okay, I dropped the vid. Easy work today. Once the job hunt is over, I literally didn't want to code for like a month. Yo, Busy, what's the name of the... Also, like, where do you work right now? I don't think it lets you post links. That's the thing. Yo, everyone, go give my video a like. I just dropped it. Let's get that thing popping. I wonder if people can't solve that question. If there's people out there that can't solve that question. Probably. But I would say, like, probably a lot more people than usual will be able to solve it. Bro, it gets so hard at like day... Mertizzi, you should see it when it gets to like day 8, 9, and 10. It's way hard. Since when did you start doing advent of code? Is that something you always did? Okay. I'll peep the landing page. Hey James, been following your content for a while. Did you stop doing mock interviews? What browser? This is ChatGPT. Yeah, I haven't been doing mock interviews for a bit because Alpha is taking over. He does a way better job at it. Alpha Code, he's solved way more questions than me and landed way more offers. So he's been running them for me instead. Why? Do you need one? He does it for free too. I'm gonna send you his link real quick. If you need a mock, Alpha's that guy right now. Maybe I'll do one. Like we'll do like a session when we get back to it. All right, let's take a look at your website. Your AI powered trading performance coach. So is this like for day trading? Is this for day trading? So you have... Oh, you dropped a little video on it?
Hey there, I'm Alpha.
Oh, that's cool how you just embedded it in here.
I'm Alpha.
Is it a YouTube video or just like a video you embedded?
Develop the right mindset, emotional discipline, and psychological edge needed in trading. My focus is on trading psychology, helping you stay consistent, manage emotions, and focus on the process rather than the outcome. Whether you're dealing with fear of missing out, hesitation, or overtrading, I'm here to guide you in building emotional control and a resilient mindset.
So what does it do? Join the first 100 traders, unlock lifetime pricing. Join the wait list. I'm going to join the wait list. Dude, I like your landing page. Yo, Paul, what's fun? I got 91. What are you talking about, Paul? What are you doing? What are you guys doing? Are you talking about like typing speed? What is that? Alpha AI Performance Coach. Is this like Alpha Code Performance? Develop a powerful trading mindset, real-time voice-to-voice coaching with emotional analysis, getting personalized guidance before, during, and after your trading sessions. Dude, your website is really sick, honestly. Like this is a really sick website. Thanks for showing me. I really like the animations. Log every trade rich context. Track conviction scores, psychology notes, chart uploads, and custom entry types. Advanced analytics. Visualize your performance with powerful insights. Yo, are you still a student? This is really sick. You have a round 1 at Google, you said? This is a really good project, honestly. Build, track, and refine your trading strategies. Oh, you graduated? So you're a new grad and you built this website out? Dude, this website is really sick. I'll definitely join the wait list. Let me join the wait list on my... I'll join the wait list on my... Let me know if you get it. On my business account. Thank you. Thanks for sharing. This is sick. Am I the first trader? Why does it say 0+ traders on the wait list? Is it actually counting it up? Let's see if it works. Woo! Yo, busy. I'm the first person on your wait list. When you have like 1 million users, you gotta remember me. You have round 1 Google. Sick. Good luck, man. Yo, this is sick. The fun thing about building these kind of projects is probably like you're probably solving a problem for yourself, right? Are you a trader? Like you do a lot of trading? Yes, so you oh yeah, it says it says busy trade like literally trades, but yeah, if you're a trader, that's sick. So now you have this AI powered trading thing, and all you do is oh number 2, the respect. Yo, everyone go sign up, man. Everyone go sign up. Cuz now you're a trader yourself, so you're solving your own problem. And now you're getting people to use your product. And then now like whenever you're at work and you learn something cool and you want to integrate it, or you're learning a bunch of cool stuff and you want to like practice it, you could like implement it into this app. So you could just this app you could probably just keep working and using for the next like for however long you want. And this is such a good side project because people actually use it. So people all the time are asking me what is the best side project to do. I was like, why don't you just make something that actually solves one of your problems? So that at least you're like solving some problem for yourself, and like maybe it'll do some good for you because it's solving some problem for yourself. And if it solves a problem for you, it might solve a problem for someone else too. And then you could get actual users. And instead of having like a super simple project on your resume, now you have one with a lot of different users. Okay. Wait, let me fix this. I'm tweaking the background. Good job, though. Alright, chat's trying to make me play this arithmetic game. The arithmetic game is a fast-paced speed drill where you're given 2 minutes to solve as many arithmetic problems as you can. Okay, I just click start. Bruh. 164 divided by 4? 160, 40, 80, 120, 41, 97, 100, 9 times 6, 45, 7 times 46, yo, how'd you get to 80? 7 times 46, 46, 92. 92 times, if you add 92 twice, you get 184. You add 184. Paul got 90, bro. I can't even do 7 times 46 off the top of my head without writing it down. Are you allowed to write it down or no? No, you're not allowed to. You just have to do it straight on your head? Yeah, you're right. Okay, oh yeah, you're right. I literally forgot how to run that. 110. Wait, 40? 80. 80 plus 50 is 130. 128. 171 divided by 9? Yo, I got cooked. I got 5. 171 divided by 9. Yo, how you guys so fast? 35. 20, 69. Oh, shit. I got cooked. Bro, I got cooked. Bro, someone clip that. Dude, that's actually fun. I might practice that. Like mental math just on the spot. Okay, where are we? Okay, let's get to day 9 again. Day 9. Yo, Paul, record yourself. That's crazy. All right. Let me just push up this code. Has anyone tried out windsurf? I haven't really tried out windsurf, but it's just the same as it's pretty much the same as like cursor, isn't it? Yeah, 90 is wild. It has all the same features, but it's worse. Get your puzzle input. Okay, we're gonna try to go for part 2 again. Of that other day. No, I couldn't get part 2 from yesterday. But somebody like gave me advice on it. Wait, how do y'all do the long division in your head? Like what's the strat for that? I get the multiplication. I see. Yeah, I don't have a proper strat for that. Closest multiplier 5 plus. Yo, we did good today. Yo, Alpha, okay, I'm gonna explain part 2 of day 9 for you, and let's see if you understand it. Let's see. So we're going to try day 9 again. So the first part, so for the very first part of day 9 was that we're in a movie theater, and the elves tell us where the red tiles are on the grid. So we're doing day 9, Advent of Code now. We need to finish part 2 because we only got to part 1. But I'll just explain day 1. So essentially in day 1, they just gave us all the red tiles. Let's see. And then all we needed to do was choose any 2 red tiles as opposite corners of the rectangle. And we need to find what would be the largest rectangle possible. So that's the part 1. It's kind of easy. You can kind of brute force it. So if you can pick any 2 rectangles. So if these are the corners, what's the area? It's pretty much just 1, 2, 3, 4, 5. We can pick like these 2. Oh, sorry. Then it'll make like this rectangle. So essentially, all it's telling you is that you need to choose any 2 red tiles, and red tiles are these hashtags. And then you just need to find the largest rectangle possible. So I just did a double for loop where we figured out where all the corners were, and then we just did a double for loop to see like the size of the rectangle that those 2, like for every 2 possible rectangle or possible red tiles, we see the size of the rectangle those 2 form, and then we just keep taking a maximum. So the biggest one that you could form is actually between these 2, like these 2 rectangles, right? So it goes something like this. That makes sense so far, Alpha? So what would your guys' solution for that be? Like we're just given these and we need to find any 2 and then just, yeah, exactly. Okay, now part 2 gets a little complicated. The elves just remembered that they can only switch out tiles that are red or green. So your rectangle can only include red or green tiles. In your list, every red tile is connected to the red tile before and after it by a straight line of green tiles. The list wraps, so the first red tile is also connected to the last red tile. So there's green tiles. So these are the red tiles, but the green tiles go this way. And they connect all of the red tiles together. Like this. In addition, all of the tiles inside this loop of red and green tiles are also green. So we essentially need to fill it in. And then the remaining tiles are left as is. The rectangles you choose still must have red tiles in opposite corners. So we still need to pick 2 red tiles in opposite corners, but any other tiles it includes must now be red or green. So this significantly lowers the options, limits the options. So for example, you can make a rectangle out of red and green tiles with an area of 15 by using 7, 3, and 11. Right? Because everything inside of it is green or red tiles. No, both. It's the same thing, like both pairs of the corners are supposed to be green. And then the rectangle that we form with those 2 points, every cell in there needs to be colored, essentially. So you can see we can form this rectangle and it's filled. We can form this rectangle and everything there is filled. And we can fill this one rectangle and everything will be filled in there, right? If we pick this point and this point, then it won't work. Like if we pick this point and this point, then it won't work, because if we make a rectangle like this, it's a big rectangle, but this is out of the like it has cells that aren't colored. Yeah, so that's number 9. What do y'all think? I kind of have a solution in my head because obviously, like, I've been trying this already, and then people have been giving me advice. But what do y'all think for solving this? Yo, my initial solution was like, you can do this with a segment tree? You solve this question? Honestly, I've never implemented or used the segment tree in my life, so that's going to be new to me. Day 11. But I've heard of it, obviously. I'll give you guys like a second to think while I'm just like adding timestamps to my video. Sorry, I'm just like, I have to add. Yeah, bang out part 1 real quick. Day 11. Reactor. Day 11. Reactor. You hear some loud beeping coming from the hatch in the floor of the factory, so you decide to check it out. inside, you find... You just check for a point A and point B. If there's a point between them that isn't on the same axis, then you can't do it. What do you mean point between them that isn't on the same axis? Like if you have this, yeah. Like if we have like a green like this, right? What if we pick 2 points here? If we pick 2 points here, we check, check, check. It breaks. Do we just need to check around the corners? Like loop? No. Oh no, this won't work because you need to capture the middle. Okay, somebody said all we need to do. So for part 2, somebody said all we need to do is like actually figure out, like how they did is like figure out the border. They figured out the border like here by just walking it. And then from there, they would just like check if everything's inside. So if we had this, then we just have to check if everything's inside. But can we check here? Like, what are all the different options? We can try this. This is good. We could try these two. This is good. We could try these. And we're good. We can try this. And we're good. We can try. Like if we try like this. Should we just do the thing when we walk around and figure out the boundary? So I think we just need to walk it and figure out all the ones that are in the boundary. Like outside. And then for each one, like look through the corners. And then just like go 1, 2. Yeah, because if we pick this, then we just start like drawing like this, we're gonna see we're out of bounds. Since we're picking any dot, we're gonna be definitely in bounds at first. So there's always going to be, okay, I think all we need to do is walk and actually count I think that actually works, where we just like define what's outside. We just like walk, okay, like we have this, right? And we know it forms a closed circle. So we just have to walk along, like follow the points, but then just like if we follow it counterclockwise, mark everything to our left. Mark everything to our left as like outside. And then we just do a double for loop again. For every dot, we're going to figure out the 2 dots. And then we're going to figure out like any 2 dots. And then we're just going to like scan, looking for any, like if we're able to scan all the cells and not hit the border, we're good. Like outside the polygon, right? We just need to know the boundaries. And since both of the points are in the boundaries, and then if we scan between them, because we'll definitely cross it. Okay, I see. This works. I wouldn't have thought of that myself, but someone gave me this. Part 1, part 2. No, I'm doing the method. This one's like super intuitive. Like, you just like walk it, and then since it forms a loop, you just form the outside boundaries. Now I think like I can easily imagine that in my head. Like if you pick any 2 points, right? Those 2 points are definitely gonna be inside the rectangle because they were a red point, right? So now that if we pick these other red points, we could just like scan and just make sure everything is green. If at any point we see a border, then it doesn't work. Because we could see like a border. Like we could even see like this point comes out. Like maybe like this. Yeah, something like this. And just like this point goes out. We have like a point here. Right? And we're gonna know for sure that like we crossed 2, 5, and 9, 7. 2, 5. Where's 2, 5? 1, 2. Oh, 2. This one? So, are you talking this one? 9, 7. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah, like here we know the green, and then we just like scan this way. And then like all we need to know is like if we ever hit like again, we just scan. Right? We're going to hit out of bounds here. And then we return false. Okay. Oh, sorry. 9, 7, XY, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6. Yo, which point are you talking about? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah, 2, 5 is right here. Bro, this thing's blocking it. That's why it's hard for me to see. Oh, sorry. Okay, yeah, you're right. 0, 1, 2, 3, 4, 5. Bro, this thing's blocking it, so it's hard to me to count it. One, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. 0, 1, 2, 3. Dude, does this thing even go to 9? 0, 1, 2. Like here? What do you mean? That's still, like, that solution's still not gonna work. Or, like, it's gonna catch that. Oh, sorry. Bro, I'm cooked right now. 9, 7. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. 0, 1, 2, 3, 4, 5, 6, 7. Yo, yeah, I was looking at this already. I was already pointing it. So if you connect these, right? When we're scanning from left to right, it's gonna see that this is out of bounds. What was your point? We're gonna keep track of all of the points that are out of bounds. So to keep track of all the points that are out of bounds, we're gonna fill out this orange. We're gonna tag all the cells as orange. How we're gonna figure out which one all of them are orange is we're just gonna walk like, because we're given all of them in like a circle. We're given all of them in a circle, right? So once we start at this one, we'll just go clockwise, marking everything to the left as out of bounds. What do you mean we have intervals? You have intervals, not just one contiguous array. Like, we're given the different points, right? Like, this is an integer. These are integers. Like something like this. Like this, right? Yeah, and then you color the outside like this. You follow. You just follow all the points. They're intervals. As you like follow an edge, you just mark the outside as orange, and it forms a closed loop, right? Now we can pick any 2 points, right? Now we form a square. we could see that like inside of it, there's gonna be, we're gonna find one of, like for the ones that are invalid, we're gonna see that like an edge that's outside. If all we see are edges that are inside or that are not equal to orange, if all we see are ones that are not equal to orange, we're good. Like we're good. If we ever see an orange, we return false. Like pick any two right here. Now form like this. Now when you scroll, if my edges are contained in the boundary, well, we're just doing a scan. We're doing like we build a triangle, then we just check every cell in the triangle. If every cell in the triangle is not equal to orange, we return true. If it ever equals to orange, we return false. And the way we get the orange is by just walking the path and then like writing and then like marking the cell to the left as out of bounds. That's how we get the orange. What's that? What's that? I haven't pulled this out in a while. Do they have dark mode? Dude, what the... Nah. See, they give it to us in like order. Does that make sense? We just follow. Where's green now? And eventually it's gonna loop back here. So I think all we need to do... Yo, it's called like Green's Theorem. Somebody was showing me this. I had to watch videos on this. So essentially, if you follow like a list of points that are given to you in an order, it's gonna like cause an enclosed space. Zero, 1, 2, 3, 4, 5, 6, 7, 8. 8 rows. Yo, we're going from the start. Zero, 1, 2, 3, 4, 13. Erico, does that make sense? Eric, does that make sense? Did you do something else? Sorry, I'm cooked right now too. Like, let's try to implement this in range. Yo, I wouldn't have been able to figure this out myself though. For you. Like, look up Green's theorem. I think like when they give you a bunch of points and they give you in order, you can form the boundary because we know that it's eventually gonna loop. So we know that like it causes an enclosed circle if we're given all of the points in like some sort of order, in like the proper order. Like there's gonna be an enclosed space. Eric, did you finish also? You already finished day 11, right? Or no? Nice. You're pretty good. What do you do for work? Where are you interning? Line dot split. Yo, you're sick. Yo, like the one thing about rows and columns is it trips it out. Like X is actually like the column and Y is actually the row. So if you want to get like Y, you have to go in the row and so it like flips it around. That's why I was getting confused when you were telling me like go 2 to 3. And it's getting late. X, Y, let's split. Let's split. Y. Split. Yo, what's up? Thanks for the hearts. What the hell? There's actually 9 rows if we include 0. Grogu, what's up? So now we just have to follow the points and draw. Grogu, have you tried this question yet? Points, dot, and So what we're gonna do is like we're gonna go from point to point. So we just need to figure out the direction of the point, and we need to travel towards that point. Mertezi, that's funny. Yo, M, it's easy. Try it out. How many questions did you solve? Seven, 1, 11, 1, 11, 7. So now we just need to like walk towards those points. What's the direction? Yeah. So the first one goes up. So we just need to figure out our direction. Our initial direction. The first one is going right, so our initial direction is equal, like pointing right. How do we figure out the direction? So there's pretty much 4 directions. We're trying to build the boundary now. What's PMO? Facts. Up. I haven't tried code signal in a while. I used to max it out though. But that was like when they only asked like basic questions. Get direction. I don't know if they changed it. Yeah, exactly. Try it out. Same X. How do you have time after 60 hours? Bro, I'm literally cooked right now, honestly. I don't... It depends. Like, right now it's kind of slow. But usually, like... Sometimes I don't stream. But how many hours do you have in a week? You can work... You technically have like 100 hours in a week. Yeah, but your mind needs to rest? Nah, I'm good, bro. I've been like literally... Yo, Mertizzi, I'll message you about it. I don't know if I can talk about it. Dude, that's crazy. Yeah, trust me, I've been doing this for a long time. Like, I'm good. I won't be able to... Same x... 0.1 is less than... If the 0.1's y is less than... Then with the other y, then we have to go up. If they're on the same y coordinate, at 0.1. This is super verbose, but I have to code it this way in order to understand it. This Advent, I'm just doing this for fun. Honestly, it's making me better. Let's reverse. Right, down. What? It's a little harder. But like honestly with like my current lead code skills, I was able to solve a lot of them. There's only like two parts that I couldn't solve with just lead code skills. Oh, we have to look at... Okay. Right down. Right, down, left, up, right. Oh, and then we need to point our background. I'm not at rippling. I wish though. Yo, Turu, what's up? What am I doing? Basically, what I'm doing is Turu, were you able to solve it? Were you able to solve this day or no? No, I interviewed for Google, but for a weird role, not like the normal SWE role. Oh, used it. Did you use compression too? Use flood fill and compression? Or no? Oh, you did compression? Yo, I still need to learn that, like how you do the compression. When you do compression, how much do you compress it by? What does it even mean to do compression? Just like I just GPT'd it once and GPT told me. But Turu, I'll tell you my approach. You pretty much just like walk it. This is not really my approach. Someone told me like to try this out, but you essentially just walk the path clockwise. And while you walk the path clockwise, at every time you're just marking the element to the left of you as as um the boundary. So we know like what's outside. Right. Now essentially we just need to pick any 2 points. Right? Now we just try to find any 2 points, and then within any 2 points, we just form the triangle and then try to see if we can like check all the cells without seeing any of the boundaries. If it overlaps with any of the boundaries, we know that it went out of bounds. Exactly. Does that make sense? Two? Yo, I'm gonna learn C++ at some point too. We're going up, we're gonna go 1, 0. If we're going down, we're gonna go right, we'll go left, we'll go like I don't know, somebody did it and they said it worked for Bro, I'm just going off what somebody have told me. I wouldn't have figured out myself, but I think it should work. For direction, get direction. Okay, now we have a direction. What we're gonna do is for I and right, what we're gonna do is like. I don't think I don't think we even need to check each cell. All we need to do is just check the rectangle, right? Yeah. Which company are you talking about? Bro, trying to get me clipped. This guy's funny. Okay, direction if up. We're gonna figure out the change in x. Change in y equals absolute value of points. Holy, you're tweaking. Yeah, I think you could just check the border of a rectangle. That makes sense. For this in range dy, we're gonna do is like oh my god, we gotta start x star y min of I got E4. But when I was at Rippling, I was a senior at like 3 years of I got a senior at like 2 years and 11 months of experience, like 3 years. It's like I barely had experience. P1 2. But honestly, a lot of like the people on my team were like also senior. But like for example, I had somebody on my team when I was at Rippling who had like 6 years of experience at Meta, and he just got put on the same level as me. There's like multiple people on my team like that. Yeah, senior is terminal. But basically, they'll just give you like a senior if you do really good on the interviews. If you flop the interviews, they won't give you senior. What's BBG? Minimum of. Okay, we just have to think of the points as points. If we're going from X to Y, other edge. What am I doing? If we're moving up, we have to do start Y. Okay, I just have to code this quick. Yo, you could already see I'm slowing down trying to implement this thing. If up. If we're moving right. Down. This should start the same. Max. If we're moving left, it should start the same. You gotta flip these. What? Ten one. Oh, we're missing one. Seven one, 8-1, 9-1, 10-1. Yo, you got this, man. You got this. Don't even worry. This stream is gonna help you. There, finally printed it. Holy. When we're going down. Yo, there's two mods. Oh, Caesar. I had to add him in because some kids were, cause he's in here all the time enforcing. Paul's getting an upgrade too. There's two mods, multiple mods. Is that fair? That's allowed. That's allowed, right? Hold up, X. Mertez. There, now we have the outer edge. Yo, I'll race you all the way. Weapon. How that X? Yo, this is so messed. Yo, that's crazy. Yo, when we all start, like when this thing started, we were like literally all just doing some random shit. Nah. Bro, I'm gonna have to like also remove. For edge inset. Holy, okay. Had to get the edges properly. Okay. Yo, if you can get to 111, that's actually like a million viewer video right there. Yo, you could also maybe check the rectangles using like a prefix sum. Nah, I don't even know. No way I'm gonna eventually solve this question. There's so much code. Alright, fixed. Is okay, now we just need to implement is valid rect. We just need to figure out like the points. Like what are the options? This is option 1. Then we have option 2, it's like this. Option this. Then we have like option like this. That's not that interesting. Or like these are the 3 cases. Dude, this is so much code. I'm sure I can get it simpler. Same x, same y, 0, 0. Same y. If they're at the same x, how do we just walk the border? So all we need to do is like given any 2 points, we need to figure out. So what are we gonna do? We're gonna get hold up, let me grab some water. Okay, we just need to figure out how we're gonna like walk the rectangle. Like given 2 points, how do we just find any point? We need to find the top left. Okay. Now the last point, I'm just like we're gonna point. So we're gonna move the one to the left. We're always gonna make it so that we have these points there, so we don't have that much cases. If dude, this is a grind. if it's the same x. Then we just need to walk. This is why people are doing like some intersection thing. Oh, that's why somebody was doing like some intersection of lines. Bro, I'm a vibe code this. Code that given 2 points, walk the border. Give me some code that given a 2 point walk the border if you create sick of this, man. Sick of this question. Where? Oh, no. What? Yo, Vercel's so nice. Can't lie. Okay, let's see. It's solving them. It's checking them. All right, solving. Let's see how fast this takes. Day 9, part 2. Run that. Oh. Bro. How do you solve this? Cursor. I did that non-local. Tripping. Okay, there you go, there you go, there you go. Anyone use Zins here? I tried it. It's pretty funny. Alright, day 9, part 2. We wrote the code. Let's see how long it's gonna run. Let's see how long it's gonna run. Hopefully it doesn't crash. Hurry up. Yo, chat, wake me up when it's done. Yo. Over, under, 100K. Let's put some bets. Run. Over, under. Bro, how do you do a chord compress? Over. Over, under 150. Bro, what the hell is raycasting? The only reason why my code is running so slow is because I added the print. Otherwise, it'd be way done right now. Hurry up, please. Let's just calculate. 496. Woo! What happened? Yo, I didn't. I didn't print the result. Wait, what? No. What happened? No. No way. That's troll. Oh my god, I didn't print the result. No way. Oh my god. I thought I was gonna sleep. 122K. How did I not print the result? That was crazy. How long is it taking to run? Holy crap. Take a nap real quick. Alright, who had career questions? We can answer that real quick while this runs. I'm not optimizing it. I'm pretty sure you can do like edge checks. Like you just need to know the edges of the outer bounds, and then maybe you could like see if two edges intersect or something like that. You can check if two... Have you ever seen the post of code quality of Meta on Team Blind? No, I swear to you, I've never used Team Blind in my life. Everyone hates everything. Everyone's so depressed on Blind. Can you survive off 10 million SF? Yo, these guys are trolling. So someone's saying, if I'm best at mobile dev, should I stay in that lane even in final internship or take the chance to learn C++ and go to a new path for more money opportunities later? You should honestly, you shouldn't limit yourself. You shouldn't be like, oh, I'm a mobile dev and I'm only going to be a mobile dev. Dude, the industry changes so fast. You need to be flexible. You need to be a generalist, especially when you're first starting. There's only some things where it pays to be a specialist. But at the end of the day, you could think of like if you're a specialist and then the thing you're specialized in is no longer wanted, then then you won't get a job. But if you're a generalist and you have a lot of, it's like diversifying, right? Like diversifying your portfolio. It's just if you understand the pros and cons of diversifying your portfolio, it's the same sort of pros and cons when it comes to diversifying your skill set for the job market. At the end of the day, it's all just a job market. So for me, like what I did is I tried to be general, but not so general where I'm spread too thin. I tried to make sure I had like some full stack of experience, some back end experience, and some AI experience, and I would apply to those three specific type of roles. Dude, what the hell, Zig? Are you watching Primogen? Is that what's happening? You're watching a lot of Primogen? Did I like my CV role? So what we were doing in my CV role is like we were taking like ImageNet models. Yo, this better work. Alright, moment of truth. If we were able to solve day 9 part 2. This has been one of the hardest questions out of the whole advent of code. Let's go! Day 9 part 2 solved! Holy. That's crazy. We'll get day 10 at some point. But let's quickly recap the solution for everyone who doesn't understand it. That take forever to run. Yo, we're gonna get all these days. So the solution was you're pretty much given all these points, all of these red squares, where the question is asking, you're given all these red squares in like a clockwise order, or not in clockwise, or in like any order, right? And then all you need to do is like follow so these are the red tiles. If you follow each red tile, the path between each red tile forms an edge of green tiles. So if you follow all of them, it eventually loops and it creates like an enclosed area. Then like also in the area is going to be green. That's literally what the part 2 is explaining. So you have all the hashtags, and if you follow all the hashtags, you have the green tiles as the edges, and then you also have to fill in the middle part with green. Then it's asking, can you find the largest square or rectangle that all of the cells within that rectangle is a green or red tile, or it's pretty much enclosed in that space. So for example, this is a valid rectangle, right? This is a valid rectangle. This is a valid rectangle. We need to find the maximum rectangle that's enclosed in this space, but this is not a valid rectangle. So the solution is pretty much we start from one point and then we draw the boundaries of the enclosed space. So we know what the outer edge is. Then from there, we just like now that we know the boundaries, and how we can figure out the boundaries is we just walk from point to point in clockwise direction, filling out or like setting the element to the left of me as an outer edge. And this is like, look up the Green's theorem. So somebody gave me this insight, is like if you follow it clockwise and then you mark everything to the left as a boundary, it forms this boundary. Like for any polygon. So now all you need to do is like find, for every rectangle, compare those rectangles, and then just see if any, and then walk the rectangle's edges, and if you are walking any of the rectangle's edges and you see the outside boundary, you know that like it can't be part of the solution, because like part of it is out of the rectangle and you need something whose every element is inside of like the enclosed space. So yeah, so you pretty much compare every single one, and for every single one you just walk the boundary, and you can see for all of the valid rectangles that we can form, if we trace the boundaries, we will never hit the outside edge for all of the valid ones. So that's kind of the solution. I'm going to be pushing out my code. It's disgusting code. It's long code. How much code? Like 100 lines. It took about like 10 minutes to run. But it works. Yeah. Day 9 part 2. I'll push up my code. But that's kind of the intuition. There's like other ways that people were solving it before. Like GPT was suggesting doing a compression flood fill, and other people in the chat also did that as well. Paul in the chat also did some raycasting, which I need to figure that out as well. So the one that I followed was like a Green's theorem. But yeah, holy crap. All right, right before midnight. What do we have left? This is the best we've ever done at Advent of Code. We have 21 out of 22 stars. This year we're going to get all the stars. And it's all because everyone has been helping out. All right, I'll catch you all tomorrow. Thanks for tuning in.
Coffee stains and name chains. I am such a loner. San Francisco bases got me slowly taking over. I can't wait to show you that I'm gonna take it over. Lico, beast mode. 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 This is not a main thing, really. I'm a coder. Coffee stains and name chains. I am such a loner. San Francisco bases got me slowly taking over. I can't wait to show you that I'm gonna take it over. Lico, beast mode. 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 Lico, beast mode.